In this video, we find the equations of the tangents and normals to parabolas and hyperbolas when their equations are given in parametric form. In this first example, we have a parabola with the equation x equals 3t squared, y equals 6t. And we're asked to find the equation of the normal at the point 3t squared, 6t. Well, we need the gradient, but we must first look at the chain rule. dy by dx is always the gradient. That is dy by dt times dt by dx. Okay, now we should always remember that dt by dx is 1 over dx by dt. So if dt by dx is 1 over dx by dt, we get that dy by dx is dy by dt divided by dx by dt. We can still think of cancelling the dt in the way that we think of cancelling the dt there. I prefer to think of dy by dx as dy by dt divided by dx by dt every time. But we know that y is 6t. If y is 6t, then dy by dt is 6. We also know that x is 3t squared, so dx by dt is 6t. Now we want dy by dx. dy by dx is dy by dt, which is 6, divided by dx by dt, which is 6t, therefore 1 over t. So that is the gradient of the tangent. We want the gradient of the normal. mn times mt is minus 1, therefore the gradient of the normal is minus t. We want to go through the point 3t squared, 6t. So using the equation y minus y1 is 6t, is m is minus t, times x minus x1 is 3t squared. Notice that this general equation gives the equation of the normal for any particular value of t. Let's suppose that we take t equals minus 1. This would give us the point, well, the point is 3t squared. 3t squared, I said t is minus 1, I've written 1. When t is minus 1, 3t squared is 3. And 6t is minus 6. And when t is minus 1, the normal is y plus 6 is minus t is 1, x minus 3t squared is 3. So that is the same as y equals x minus 9. So we have a way of finding the normal at any point if we just happen to know the value of t. Another value of t, let's take t equals 2. If t equals 2, the point that we have is 3t squared. 3 times 2 squared is 12. 6t, 6 times 2 is 12. And the normal at this point is y minus 6t, that's y minus 12, is minus t, that's minus 2, x minus 3t squared. 3t squared is 12. If we sort that out, we get y equals minus 2x. And then after the minus 2x, we get plus 24 plus another 12 gives us plus 36. So that gives us an idea of what we mean by the equation of a normal in terms of t. We should have a picture of what's going on down here. And you can see that at the point when t is -1, at the point 3 minus 6, we have y equals x minus 9. Y equals x minus 9 has gradient 1. That looks all right. And y-intercept -9. Not bad. And at the other point, when t is 2, we have the point 12, 12. And here we have the line y equals -2x. -2 is pretty steep down there, plus 36. And if your imagination is good enough, you'll probably believe that actually it will go through 36 on the y-axis. Well, now let's have a look at another example. This time we have a rectangular hyperbola, and its parametric equation is x equals 3t, y equals 3 over t. Find the equation of the tangent at the point 3t, 3 over t in terms of t. So again, we need the gradient. That is dy by dx, and that is dy by dt divided by dx by dt. dy by dt, y is 3 over t, so dy by dt is -3 over t squared, divided by dx by dt, x is 3t, dx by dt is 3. So we get -1 over t squared. That's the gradient of the tangent. We want to go through the point 3t, 3 over t. So the tangent through that point must be y minus y1 is equal to m, which is -1 over t squared, x minus x1, which is 3t. Multiply up by t squared, and we get t squared y minus 3t is equal to minus x, minus minus is plus 3t, and so we have that x plus t squared y is equal to 6t. This general equation gives the equation of the tangent for any particular value of t. So let's look at the tangent at t equals 1. T equals 1, we've got the point 3, 3. 3 times 1, and then 3 divided by 1. And the tangent, when t equals 1, if we take t equal to 1, we get x plus y equals 6. That's taking t equal to 1. So the tangent is x plus y equals 6. Let's take another value of t and work out the tangent at that point. T is -2. When t is -2, we get 3 times -2 is -6. 3 over -2 is -1.5. So we have the point -6 minus 1.5. My tangent now is going to be, putting t equal to -2, I'll get x plus -2 squared is 4, x plus 4y is equal to 6 times -2, that's -12. X plus 4y equals -12, which I'm going to rewrite as y equals, take the x over, divide by 4, minus a quarter of x, divide the 12 by 4, you get -3. And we could go on and we could find the tangent at any point. That's the advantage of using the parametric form like that. In this case, let's have a look and see if that is something which bears out. We have the tangent at 3, 3 when t is 1. T is 1, 3, 3. The tangent is x plus y equals 6. Goes through 6, 0, 0, 6, x plus y equals 6. And when t is minus 2, we have the point minus 6 minus 1.5, minus 6 minus 1.5. The tangent is y equals minus a quarter x. So gradient of minus a quarter, minus 3, goes through the point where y is minus 3 on the y-axis. And more about this can be found in your textbook FP1 on pages 57 to 60.